Dear participants, welcome to Second International Conference on Advances in Electrical, Electronics, Energy and Computer Sciences. We are in session 4 now and we have 6 papers to be presented in the session. So each participant will have 10 minutes to present their studies. So the title of the first paper is Short-Term Wind Energy Production Forecasting and Target Plan Selection Based on Methodological Data Using Empirical Mode Decomposition. You can start.
Hi, good morning everyone. My name is İsrafil Karadöl and I am a member of staff the Department of Electrical and Electronic Engineering at Kilis 7 December University in Kilis, Turkey. It is my pleasure to present our research today. The title of work is Short-Term Wind Energy Prediction Forecasting and Target Plan Selection Based on Meteorological Data Using Empirical Mode Decomposition. Keyword Wind Energy, XG-based Empirical Mode Decomposition and ICEEECS. Content, introduction and motivation, material and method, finding and conclusion. Introduction and motivation. The core goal of this study, we identified the most stable wind power plant for accurate for short-term prediction forecasting. The methodology employed was sufficiently robust. The hourly methodological data from ICEEECS throughout 2022 were utilized in this study. The data was proposition using the empirical mode decomposition method. This decomposition yielded a substantial amount of input data, specifically 56 distant IMF signal. The XG-based model was then tested using prediction from data 52 different VPP in the region. The performance of the model was evaluated by means of R-square, MIA, and MCA metrics. Introduction and motivation. Global energy demand is increasing daily. However, utilization conventional search to meet this demand has been demonstrated to result in substantial environmental repercussions. Furthermore, is acknowledged that these research are finite. Their depletion is recognized as a significant global concern. The most effective approach to this challenge is the utilization of renewable energy. The transition of state toward the utilization of renewable energy can be attributed to the environmental benefit and sustainable characteristic it offers. However, renewable energy is not without its limits. Sources such as wind have been observed to exhibit random generation characteristics. This incredible process significant economic and technical challenge for the operator responsible for managing the electric grid. The most effective method of mitigating this volatility is to ensure the precise measurement of energy prediction. Literature gave a substantial body of research has already been conducted in the field of short-term wind forecasting using machine learning methodology. XGBoost is a popular and effective tool that offers high accuracy, flexibility, and computational efficiency. However, a particular use was identified to the best of the author knowledge. There has been no research in the literature focused on forecasting for different targets at a 1 hour horizon. The present study specifically addresses This uses by testing XGBoost models performance for various VPP target at this critical 1 hour time frame. The objective is to fill that void. Material and method. Meteorological dataset. The primary input data for this study were meteorological information. The focus of the study was on the province of Izmir for a period of 1 year. The period under consideration extends from January 1st to December 31st, 2022. The resolution of the system were hourly. Statistical properties of meteorological parameter. We used 8 different parameters, including cloudiness, humidity, radiation, wind rotation, wind speed, air temperature, soil temperature, and rainfall. VPP data, VPP generation dataset. The output data compares the actual VPP generation data. The present study utilizes real-time hourly data for 2022 from a total 52 different VPP locations in Izmir. Collectively, this plant constitutes a substantial proportion of the total capacity, with an installed capacity of 107,042 MW. The range of plant including in the study varied from 3 MW and 2026 MW. The Turkish Electric Transmission and Distribution Co. provided the following crucial information. Empirical mode decomposition. Before running XGBoost, we proposed the meteorological data using the empirical mode decomposition method. Empirical mode decomposition is the best way to break down complex signal. It's converted each meteorological parameter into 7 IMF signal. Given the 8 meteorological parameter, the input matrix was subscale. Our model is supported by a total of 56 IMF signal. And the feature is a prime example of how we use the empirical mode decomposition method, our input data with speed parameter. Our primary forecasting model was the XGBoost algorithm. It is powerful machine learning tool based on decreasing tree. It is held in high esteem due to its superior speed, accuracy, and resilience to problems like overlearning when compared to conventional method. Its secret lies in the gradient boosting. It is incrementally trained successive decreasing tree, specifically corrected the prediction error of the previous model. XGBoost model parameter. We optimize our model using specific parameters. Finding. Here are the result of the performance evaluation. He saw a massive variation across the 52 power plant. VPP 25 of performance was overstating. Archive and R square of 0.0 938. This indication an extremely accurate prediction. But consider the other side of the spectrum. VPP7 performed poorly with an R square of just 0.555. The huge difference provides that location is crucial for forecasting wind power. Conclusion. Our main conclusion is crucial. Using meteorological measurement data and all VPP prediction data within the same provincial boundaries together for forecasting it is not always effective. The difference in accuracy are striking. We have identified two key reasons for this. First, there are geographical location discrepancies. The water station and VPP are not close enough to each other. Second, even within in the same province, same plant face endemic meteorological conditions specific to their small region. It is clear that site-specific analysis is vital for reliable wind energy forecasting. Thank you. Answer at question and answer.
Okay, thank you. Are there any questions? Okay, let's go with the next paper. The title of the paper is Analysis of Power Quality in Industrial Environments Using Synchronous Meshes, a Case Study.
Hello everyone.
Hello, you can share your screen.
Full screen, no. You-
We are waiting for you to share your screen.
Yes, but do you see?
No, we cannot see.
Why? Terrestrial. In this moment, do you see?
Yes, we can see and you can start.
Hello, my name is Marin George Andrei. I'm student to University of Galați, Romanian, and I present analysis of power quality in industrial environment using the synchronous machine case study. The study proposed the power quality is a key concern in industrial environment where large load and continuous process demands electrical infrastructure. The synchronous machine play a central role functional as generators, motors, or condensers, capable of regulating voltage and manage reactive power through excitation. However, rapid load variation in the heavy industry, such as hot strips, rolling mills, often case disturbance, including voltage sag, harmonic and low power factor. This study investigation 4.2 megawatts and the voltage is 10 kilovolts synchronous motor The methodology in this chapter present the methodology framework for analyzing power quality in an industrial environment using a synchronous machine in a hot strip rolling mills. The approach combines real-world class A measurement, simultaneous modeling in MATLAB, Simulink, or Python, and benchmarking against international standard. The measurements were conducted over 7 days across a scenario included startup, steady state, load rejection, dynamic rolling cycle, and idly operation. The power equality indicate asset where THD power factor, active, reactive, apparent power, voltage, imbalance, and flicker. Compared with standards. Advanced tools such as FFT, time correction, heat maps, and energy loss estimation were applied for deeper analysis. In this graph, in this picture, present the distribution network to alimentate the synchronous machine. Sorry. The results analysis from the simulation synchronous machine is the first pictures present the variation of the phase voltage. The oscillation are primarily associated with the highly dynamic loads profile of the hot strip rolling mills, where rapid change in torque demand led to transient deviation in phase. The second picture present the evolution, illustrate the evolution currents. The current value remain closely aligned across the phase, indicate good system balance. Dynamic variation are observed to the rolling mills load circle, but no major unbalance at present. The first picture illustrates the frequency analysis. The value remain very close to the nominal level of the 15 Hz. The last picture present the power factory. The power factory value remain high for most of the interval, indicate an efficiency and well compensation operating regime. Single variation at higher current reflect the influence of reactive component and the dynamic of the industrial process. The trend line confirm the overall stability of the power factory with respect to current damage. The active power illustrate the first picture illustrate the active power. The value remain close to the nominal operating range with fluctuation characteristic of the process where the load is highly dynamic. The overall stability of the curve confirm confirms the efficient operation of the motor and its ability to adapt to the variable damage of the industrial installation. The last image present the reactive power. The value remain close to the nominal operating with fluctuation characteristic the process. The last pictures is the reactive power. Highlight the compensation variation of the synchronous motor. The observed fluctuation reflect the adjustment of excitation to the dynamic rolling mills regime. Confirm the essential role of the machine in maintaining voltage stability and keeping the power factor with accepted limit. The conclusion, the study analysis of the power quality, impact of 4.2 megawatts synchronous motor supplied at 10 kilovolts and integrate into a hot strip rolling mills by cabling real world. The power quality complex, dynamic load behavior, excitation and reactive power control, simulation validation, industrial relevance. The integration of synchronous machine in industrial environments provide not only mechanical drive capacity, but also significant benefits for grid analysis and power quality management. The synchronous machine, where properly integrate and control, can significantly enhance power quality in industrial environment. Thank you very much.
Okay, thank you. Are there any questions? Okay, let's go with the next paper. The title of the paper is TabM versus traditional ML for e-commerce product ranking, a multi-signal framework for frequently bought together recommendations.
Hello, it's our paper. I'm sharing my screen.
Okay, you can share.
I'm trying.
Okay.
I think there's an authentication problem. I'm trying, but
maybe you can leave the meeting and enter again.
Yeah. Okay, I'm coming.
Okay.
I'm sorry. I'm again trying. Authentication is disabled. There's a problem in my settings. I'm really sorry about this problem. If we can wait, I can use my other computer. So I will attend with this, but maybe the next person can present also, as you wish.
Okay, I will announce the next paper. The title of the paper is Analysis of Battery Management System.
Sorry, please, next paper, because I don't okay to presentation. Thank you.
Okay. The title of the next paper is Generative AI for Synthetic Sensor Data Generation in Embedded Systems. Okay, the title of the next paper is Integrated Analysis of Student Surveys with Machine Learning.
I think they are not here.
I guess they are
Maybe.
here, but
I'm sorry. I'm sorry.
Evgenia Rakita Kureshi, I think you are here. Do you want to present now? So whoever wants to present, please tell me. Whoever is ready, please tell me.
Hello, can you hear me?
Yes, you can try again.
Okay.
Yes, we can see your screen.
Okay, thank you very much. I'm sorry about the disturbance. Can you see also right now?
Yes, you can start.
Okay. Hello. We are actually from Hepsiburada, from Turkey. My name is Dilge Karakaş. My friends also helped me about the experiments and also the paper, Enis Teper and Okan Kaya. I'm really happy about their contributions. Our topic was actually about a product ranking model that we are trying to develop. We tried several different machine learning models and actually benchmarked them and checked if we can use it in the production setting with our minimal latency policy. So we checked a few things, and also we have tried an logistic regression also with information value. And actually, these are the results of our trials. Firstly, what was our challenge in that case? We need intelligent product ranking for frequently both together. We have a retrieval layer for that model. But after that, we haven't done any ranking for this model. So it was a fresh start for us. And when you check the business impact for that, actually using some features of the products that shows the product's quality for a ranking model in frequently both together, we actually can see an increase in our average basket value and also in the conversion rate at the Hepsi Burada. After using some convergent type of features of the product, you can see better options. You can show better options for the customer. Actually, our current limitations was simple restricts miss complex purchase patterns. So we need a model that we know is powerful, and also in the production systems, we need a balance between accuracy and latency. We do not want a really huge model that we cannot deploy and use it in our website or application. So our approach is actually TopM was a candidate, and also there was traditional machine learning models, actually not maybe traditional, but tabular machine learning models that we know that they are powerful, like random forest, like GBM, CatBoost, XGBoost type of models. And our end results show a significant improvement in hit rates at 5 with a good amount of serving latency in our case. So our actually contributions seems like there is a systematic comparison of neural approaches and traditional machine learning approaches. And also in the comprehensive feature selection analysis, we have used weight of evidence, binning, and information value that maybe we do not see much in ranking settings or e-commerce settings. We have seen that scorecard logic maybe in the finance a lot more, but in that sense, we haven't seen much. And also performance complexity trade-off analysis for practical deployment. We have done this. Actually, our journey starts like this. We are collecting the data, and that is our pipeline actually. We have users, and actually we are recommending some frequently both together. And at the same time, of course, there are some orders of the users. When they click a product, they are seeing frequently both together products, and they love or they do not love the products, and they order or not. And if they order in a short amount of time after seeing the recommendation, our target would be 1, and otherwise for that product, our target is 0. So it's a binary point-wise ranking problem. And after we are merging the events, we are actually trying to give more info about the features, so about the products. So we engineered a few different features for that sense and merged the events also, and that was our pipeline, actually, data collection pipeline for the training phase. So what was our feature groups, actually? I'm sorry, in the bullet points, we are also seeing the binary target, candidate purchase, product purchased after main product view. So in what we show as frequently bought together, what did the customer bought or not? In the feature groups, we have similarity and position. That is actually the position after the retrieval layer. So in our frequently bought together for product A, we have candidate products, like 10 different products, candidate products that we are showing to customer. And their position, of course, is a really important feature of the ranking model. In this second group, we have categorical matching. We have categories of both the query product and the candidate product. So if they are matching or not is a really important feature. Also, if their brand is the same, it shows a good signal for the ranking model. We have engagement metrics like views, clicks, and also performance ratios like click-through rate, conversion rate. These are classical features for ranking models, and commercial signals like price, reviews, and drive features. We have composites that we derived in Hepsi Burada about the feature. And in the feature selection phase, actually, we have used information value. We are seeing information value in the scorecard logic in finance, actually. And it showed us a few different insights for the model. And at the first time, we were trying to develop a logistic regression model. So it was really important at that phase. But also after we switched to more like TopM and XGBoost type of models, it seems beneficial again. In the system architecture part, what is our actual ranking and frequently bought together looks like? For the users, they are using e-commerce and there is some clickstream data. It goes to an embedding model. So it creates a metadata generation. And also it has an interaction with the product metadata generation at that phase. And after that embeddings, we are actually indexing them. And while indexing them, we also are trying to use the product ranking API with this metadata. And after indexing them, we are actually serving them with our API with using that index repository. And after you find out a candidate number, like you can say 50 or 70 or 100 different frequently bought together candidates, we are ranking with product ranking API and show the customers most important of them, most highly ranked of them. So actually, it is saying what I showed you. There is some candidate retrieval with product embeddings, and then we have a feature enrichment. There is a ranking inference, and then response delivery. We have a JSON that we are sending to the front end. So our candidate model, what is TopM actually? We think it is promising because it is like Yandex developed TopM, and also they developed a CatBoost, and the CatBoost is one of the best tabular models when we see the benchmarks, or also we see it in the e-commerce setting. So for the TopM, actually there is a parameter efficient neural ensemble, and also they are offering some batch ensemble mechanism that when you look at their paper or their GitHub, you can see actually what TopM's real spirit is: strategic weight sharing through learnable adapters. So with that, it is fast, and also it is a usable neural ensemble that we can use in tabular cases. And core architecture looks like this. I'm not going to detail with the formula, but you can check. For our case, also, we have tried a few different configurations, and the best one is 32 different ensemble members, 3 layers, and 512 hidden dimensions. And for the training, we have used AtomW optimizer and a focal loss, because we have an imbalance setting in our problem. Models that we compared, as I said, actually TopM, CatBoost, XGBoost, Random Forest, and Logistic Regression, plus position baseline. What is position baseline? After the retrieval, actually what we show to customers success rates, success rate, we can say it like this. And our evaluation metrics is classical, actually, recommendation or search metrics: hit rate 1, hit rate 3, hit rate 5. We check the NDCG in that case, and also the precision. And after that, we actually narrowed our options, find out like actually 2 of them. We are checking hit rate at 5 and NDCG at 10. And when we are trying to do hyperparameter optimization, we are actually using hit rate at 5 as our performance metric. And also we check the production constraints in that case. When we compare the models, in that sense, we have a good achievement for TopM. Actually, we didn't expect that in the first sense. But it seems like it has a really good success, maybe with our settings and with our problem type, but it is successful in the both of in all of the metrics. We are seeing an improvement over CatBoost, second best model that we can say, and TopM achieves 23% improvement in hit rate at 5 over position baseline, and achieves 14% improvement in NDCG at 10 over logistic regression problem. What was our results actually look like? In the left, actually green outlines represent a purchase actual co-purchase. And in the left, you are seeing that for the Android phone, in the upper side of the line, we are seeing that phone case, screen protector, charger, some lens protector, and Bluetooth earphone. And actually, Bluetooth earphone was bought by this customer. We actually, with the ranking model, we changed the ranking, and Bluetooth earphone we are seeing in the first place. So it is what we want to create actually. And actually in this second example, in our laptop example, we are seeing that laptop back is at the second position, and mousepad that the customer bought is not in the first 5 position. So with our ranking model, we actually increase the visibility of the laptop back and mousepad, and also maintained a diversity while improving relevances, we can say. Our key findings is actually a really nice tabular neural performance. It is not a expected thing maybe, but in our case it happened. So TAPM outperforms all traditional machine learning approaches across all metrics, and also like the batch ensemble mechanism really challenge for our case gradient boosting dominance in tabular cases. Thank you very much. If you have further questions,
Okay,
I'd be glad to
thank you
answer.
for your presentation. Are there any questions? Okay, let's go with the next paper. The title of the paper is Analysis of Battery Management System. George, Andrea, Marie, are you ready to present?
Hello, do you see?
Yes, you can start.
Hello, Mm, my name is George Andre Marian. I present the analysis of battery management system. The battery management system in the context of the global shift toward renewable energy and energy storage, as lithium-ion battery dominate the market to their high energy density and efficiency. The BMS plays a crucial role in monitoring parameters such as state of charge and state of health, cell balancing, and thermal management to ensure safe the reliable operation. The paper presents the methodology framework and the real-world case study on 264 kilowatt lithium energy storage system, demonstrate how BMC enhance efficiency, reliability, and compliance in hybrid renewable application. The methodology present for analyzing the battery management system of 264 kilowatts lithium energy storage system. The system uses synchronized sensor for voltage, current, and temperature, ensuring precise data acquisition. SOC is estimate truth column counting, extend Kalmar filter, and machine learning model like random forest and neural network. The SOC estimation employ deep learning, virtual increment, capacity analysis, and multimodal approach combined field data. The cell balancing and protection mechanism prevent uneven again and ensure safety. The thermal management subsystem maintains safe temperature using active or passive cooling, fault detection, reliefs, one model biased and data drives anomaly detection. All methods are evaluated using accuracy, robust uh, computation efficiency, and complies with upload standard. The methodology ensures comprehensive BMC performance assessment under real-world conditions. The standard and the regular framework, this chapter review international and industrial standard governing the design, safety, testing, and performance of battery management system, focusing on the latest 2025 updates. Key standard include which define test for thermal and fire propagation. The case study is battery bank to have 2064 kilovolts lithium energy storage. The photovoltaic is the 18.6 kilovolts. I have in this system three inverter furnace. The grid three furnace inverter to the 30 kilowatts. When energy storage is managed by 38 watts each one battery management system for protection, balancing, and control. The power exchange between the battery and the HVAS is and by the 6 energy converter, allowing bidirectional power flow. The system maximizes renewable energy use, enhance power quality and reliability, and offer modularity and scalability. The integrated BMC ensure operation safety and efficiency, demonstrate how coordinate photovoltaic and battery system can provide flexibility, resilient, and sustainability energy solution for modern smart grid. The in the first picture present the state of the charge. Illustrate the daily charge and discharge profile of battery system. At the beginning of the simulation, the shock is set approximately 15%, representing a partial charge condition. The last figure illustrate the power flow diagram in dynamic interaction between the photovoltaic system, load, damaged battery storage, and the grid during a typical day. The result confirmed the integration photovoltaic panel, and storage draws bidirection converter provide flexibility and reliability operation with the battery efficiency acting as buffer between intermediate generation and fluctuation loads. The first figure illustrate the simulation result, demonstrate the AC bus voltage stability. The nominal voltage of 4000 volts was maintained with a tolerance of plus minus 3% in compliance with integration grid codes and standard. The last image illustrate the harmonic distortion analysis curve. The THD values over get around 1.5% with minor oscillation liquid the transition between charging and discharging of the battery. Even in periods of high load damage or rapid fluctuation in PV generation, the THD did not exceed 2.2%, demonstrating the ability of Victron convert to efficiency filter and regulation harmonic components. The conclusion in this paper, analysis of hybrid photovoltaic battery system, simulation evaluate efficiency energy, operation stability and power quality. Results show that the system achieved 85% renewable safe consumption with the BMC maintaining SOC between 90% for optimal performance and longevity. The Victron converters ensure small grid interaction and voltage stability with 3%, while THD remained below 2.5%, complying with standard. The modular design enhances redundancy, scalability, and reliability system. Overall, the study confirmed the BMC integration with PV battery system significantly improve efficiency, safety, and power quality, offering a robust path towards smart, sustainability, and flexibility energy infrastructure. Thank you very much.
Okay, thank you. Are there any questions? Okay, the title of the next paper, Integrated Analysis of Student Surveys with Machine Learning. Evgenia Rakitina Quereshi. You can share your screen.
Hello, can you hear me now?
Hello, we can hear you.
Morning to everybody. I'm trying to share my screen. Let's see. Is it visible? Oh,
Yes,
okay.
we can see your screen and you can start.
Okay, thank you very much. Good morning, dear colleagues. I want to present you our paper integrated analysis of student surveys with machine learning. Our team is from Varna Technical University, Bulgaria, and I will present briefly what we achieved and what experiments we did. First, I want to explain the reasons why we were so interested with student surveys and to get as best as possible insights from them. This is because the student surveys not only inform us for whether the students are satisfied or not with the education course, but also can make us take some strategic decision and predict the future actions and satisfactory of the next generation of students coming. And this is all possible if we use the machine learning, AI and machine learning methods. And the one we used actually to test the results are decision trees, random forest, and we try to compare the outcomes of their results, the results we gained, and we combined the quantitativity and textual responses and measured the impact, which was concluded. So data pre-processing is one of the most important parts to prepare the data for the machine learning methods. And it's many stages of preparation, which has to make the data set ready to be processed by AI. I will not waste your time with this. Probably all of you are aware of the process. It is quite a long process. The models which we tried, many models we tried, and this is logistic regression, decision tree classifiers, random forest classifiers, and all of them are visible for you. I won't read them, but we wanted to just to decide which one is the best for the data sets we had. And evaluation was fivefold cross-validation, and the metrics we mostly were interested is accuracy, precision, recall, and F1. Reproducibility, we use Python, skit1, some configurations for all models, and the best now is to explain the experimentals and the results and conclusions. This figure, which I present to you, illustrates the accuracy score, which is obtained by evaluated algorithms of the public dataset. The ensemble-based models achieved the highest result, which we can see with the gradient boosting, which is 0.978, and random forest 0.976, which we also can see. And histogram-based gradient boosting also need to be mentioned at 0.972, slightly outperforming all other approaches we used. This confirms the strong generalization ability of tree-based ensemble method. A single decision tree reached 0.941 accuracy, which is here at the beginning, which, although we see it's not bad, it's relatively high, remains significantly lower than its ensemble counterpart. And this, I can say, highlights the benefit of aggregation in reducing variances. Support vector machine also, we noticed that performed well with linear support vector machine, 0.9 ICEEECS2025-2, and the support vector machine with RBF kernel 0.95, exceeding the performance of logistic regression itself, which is 0.94 here at the middle. These results suggest that margin-based separation and nonlinear kernel provide more robust classification, I could say, boundaries compared to linear probability-based models. The lowest accuracies we can notice were recorded by Gaussian naive Bayes 0.857 here lowest, and K nearest neighbors 0.874. And of course, the last multi-layer perception 0.882, indicating their limited suitability for this particular data set, which we were experimenting with. Their weaker performance may be attributed, we think, to sensitivity to feature distribution assumptions, neighborhood parameterization, and sorry, I have sore throat, suboptimal hyperparameter tuning. Overall, the accuracy analysis, we can say, firmly confirms the superiority of assembled classifiers with SVMs as strong alternatives. At the figure 1, we can see that it presents the average precision values for the 10 evaluated algorithms on the public data set. The assemble-based method achieved the highest precision with gradient boosting we see at the top, and random forest, and histogram-based gradient boosting, the top one here we can notice. And we see they outperforming all other approaches which we use. These results confirm the advantage of variance reduction and aggregation in tree-based assembles, which provide more reliable decision boundaries compared to single decision tree, for example. Along the linear models, linear support vector machine showed higher precision than logistic regression again in this, and suggesting that margin-based separation is more effective than probability-based classification in this particular case we studied. The support vector machine with the RBF kernel achieved 0.891, demonstrating the benefits of nonlinear kernels, although still below the ensemble method. And again, we see much lower performance of the models like K near-set neighbors or Gaussian naive Bayes. And this actually repeats the conclusions of the previous figure. Figure 3, which I present to you now, shows the average recall values obtained by evaluated algorithms on the same public data set we use. And the highest recall was achieved again by gradient boosting and random forest and histogram-based gradient boosting, confirming again the superior ability of ensemble methods to correctly identify positive cases. Because in a recall, we actually evaluating the predicted positive cases by the machine learning algorithms. The support vector machine with RBF kernel also reached quite good level of performance, guessing the true positive predicted answers. And it is a strong alternative with minimizing false negative, which is critical, because we not only try to be good in guessing and predicting the true positive, but we also want to minimize the false negative. Decision tree performed reasonably well here, but it was clearly the decision tree outperformed by its assembled variant. Among linear models, we could say that logistic regression, because if we compare the linear models among themselves, we could say the logistic regression and linear support vector machine were the one who showed lower legal, indicating that they missed a larger proportion of positive instances compared to more advanced approaches, which we just spoke about. At the figure 4, we evaluate the average F1 scores of the evaluated algorithms on the public dataset. Gradient boosting achieved highest score, and closely was the score of the random forest and histogram-based gradient boosting. And this result confirmed that assemble-based classifiers not only balance precision and recall effectively, but we could say that they also deliver the strongest overall performance, because that's what F1 score is evaluating. The support vector machine with RBF kernel logic reached 0.91, including a robust trade-off between precision and recall, while the linear support vector machine was lower than it and performed moderately, reflecting their limitations in capturing nonlinear decision boundaries, because when we study data sets and with machine learning, the most crucial is to handle properly the nonlinear decision, the nonlinear questions and surveys, part of the surveys. The lowest F scores we see here are by k-nested neighbors and also Gaussian naive bias and multi-layer perceptors. So we come into the final conclusions that on the 3-class student survey task with 5-fold CV, ensemble 3 models give the best and the most stable result. We not only searching some method to give the best result in some of the experiments and results, but we want to have the stable results all through the different recalls, accuracy, F1. So we want to have the stable result. Gradient boosting, random forest, and histogram-based gradient boosting led on accuracy, precision, recall, and F1 showing stroke generalization. SVM and RBF kernel was a close runner-up, especially useful when recall pure false negatives is the priority, because for every survey, for every machine learning to predict some answers of the students, we need to know which is our priority. And if our priority is pure false negative, so we could choose these two methods instead. And logistic regression and linear SVM were reliable. All compute baselines, that's their strong part, that they demand less computing power with mid-tier scores, while K, NN, Gaussian, naive Bayes, and MLP underperformed here without extra tuning. Bottom line, the photo ensemble trees use RBF CVM when recall matters and keep linear models as fast baselines. They're fast, but we see that their performance is quite more moderate than the one which is like the one we mentioned, like random forest. This paper is supported by the scientific project Integrated Approach for Analysis of Student Surveys through statistics and machine learning. And this is a project in our university, Technical University Varna. It's financed by the Ministry of Education and Science. Thank you for your time and my apology for being killed.
Thank you. Are there any questions? Okay, we completed all the presentations. Dear participants, on behalf of organizing committee, I would like to thank you for your scientific contribution to the Congress, and we hope to meet you in next Congresses as well. Now I am ending the session. Thank you.